Right, morning folks. Last lesson you guys had a look at something called Ohm's Law. You had to go do some calculations regarding that. I thought we'd have a chat through that and we'll look at some of the factors that affect resistance. So, let's have a look. So, before we start, let's have a look at these different circuits here. These circuit symbols here are all different types of resistors. This is a resistor. What have these got in common with the others? Well, they all have the same sort of square rectangular box. This is a fuse. Looks like a resistor, but there's a wire in the middle, and when it gets too hot it melts. This down here is a variable resistor, and the way I remember that is you've got a resistor with the dial on it so you can turn it left and right. This is a light dependent resistor, so you can see the light hitting that. So again, the resistance depends on how much light hits it. And this is called a thermistor, so it's a resistor with a thermometer really. It changes resistance based on temperature. So, what are resistors? We think about current being the flow of electrons around a circuit. Depending on what things slow them down, that's going to be the resistance in the circuit. So you can see on this assault course here, there's certain areas where these electrons are going really fast. They can go fast here because it's nice and wide, but when they get here, they're slowed down, and here they're slowed down as well. So that would increase the resistance in that circuit. That would slow down the flow of electrons, slow down the current. So current is the measure of the speed of flow, the rate at which the electrons move around, the rate of charge moving around a circuit. And anything that slows that down, anything that reduces the current is called resistance. So resistance is a measure of how hard it is for electrons to move in a circuit. And if something slows them down, they are high resistance. Okay. Now why does that happen? That's because the electrons are moving, and as they're moving they're colliding with the metal ions in the wire. There's tiny metal particles in the wire. Those particles are vibrating all the time. When they get hotter, they vibrate more, and every time the electrons bang into them, that makes them warmer as well. Okay, so that's why all electrical appliances get hot. They waste some energy as heat. If you've got a phone charger, that gets quite hot very quickly. If you've got a kettle, that's very high resistance, that gets hot very quickly. That's caused by resistance. So let's have a look at what this means. So a resistor is something that's designed to slow down that circuit, designed to reduce the current. Okay, a variable resistor can be changed. We'll look at how we can do that a little bit later on. But a fixed resistor has a resistance that remains the same, and that's useful in certain circuits because you maybe want to reduce the current to protect certain devices, components within that circuit. So here's an example of a resistor you've got at home. The kettle has a massive thick wire at the bottom. It's got a really thick loop of metal. That's very, very high resistance. And because it's very, very high resistance, then as electricity passes through it, it gets incredibly hot very quickly, and that causes the water to boil. So you can investigate resistance by setting up a circuit with a variable resistor here and a resistor here, and you measure the current and the voltage. And if you change the voltage, you can see that the current changes as you go through, and you can sketch a graph. And last time when I set you work, that's what you did. You sketched a graph and you got a nice straight line going through. If you got a nice straight line going through, that's because of something called Ohm's Law. You should have got a graph that looks like this. If you get a straight line graph of voltage versus current, we say the thing obeys Ohm's Law. The equation for Ohm's Law is V equals I times R, or R is V over I. Resistance is the voltage divided by the current, the push divided by how many electrons go through it. And we use the symbol omega, this Greek symbol here, for ohm, named after George Ohm, who really discovered this. If you do a voltage current graph like you did last time in the work, and you get a nice straight line, we say it obeys Ohm's Law. And now when you did it, it didn't, and that's because a lot of real life things actually don't obey Ohm's Law over a very large range, particularly bulbs. Bulbs do not obey Ohm's Law directly. You get a curve on your graph, which is what you guys saw when you plotted it. So what is Ohm's Law? Ohm's Law is V equals I times R. Voltage is current times resistance. And you can rearrange that into R is V over I, resistance is voltage divided by current. Or you could rearrange that as current is voltage divided by resistance. So voltage is measured in volts, current is measured in amps, resistance is measured in ohms, and you had a go at doing some of these equations for me last time, and thank you for those people who submitted them. So, what does that tell us when we rearrange it? What it tells us is that Ohm's law tells us that voltage is current times resistance. It tells us that the resistance is voltage divided by current, and current is voltage divided by resistance. Current and voltage are proportional to each other, which means that when you increase one, the other increases by the same amount, because the resistance is constant. Right? That straight line on the graph tells us that it is constant. So, using those equations, what I'd like you to have a go at doing is to fill in the blanks on here. So if you pause the video, have a look at that, calculate the resistance, the potential difference in the current using those equations, and see how you get on. So pause it now. I'm going to show the answers in a couple of seconds. 3, 2, 1. There we go. Those are the answers there. Check your answers, see how you got on. Right, that's where we got to last time. That's what you should be able to do. So how do we investigate resistance? How do we find out what factors affect it? Well, the resistance of a wire depends on a number of things. If you think about flowing of electrons, the material the wire is from is going to make a difference. So plastic is much higher resistance than copper, for example. Different metals have different resistances because there are different metal ions in them. The length of the wire is going to make a difference. It's much harder to get down a long wire than it is down a short wire. The thickness of the wire will make a difference. And the temperature will also make a difference as well. And that's why the bulb didn't obey Ohm's law, because the bulb got hot, and when it gets hot it changes the resistance. Okay, so copper, for example, is a lower resistance than nichrome wire because it's a different material, and that's why we use it a lot in wiring. So, how can we investigate this? What can we do? Well, we can do a simple experiment to measure the length and thickness and how they affect resistance. Now, this is a required practical, which is one we would hopefully do when we get back to school. So let's have a look. So, this is what we can do. Well, we can set up a circuit like this. Here's a voltmeter, which is in parallel across the wire. There's an ammeter there, which is in series. We have a cell, we have a bulb, and we have a switch. So if I put a short wire in and turn it on, I've got voltage 2.6 volts. I've got a current of 5 amps. So resistance is voltage divided by current. 2.6 divided by 5 gives us 0.52 ohms. So the resistance there is just over half an ohm. If I lengthen that wire, if I swap it for a longer wire, will the resistance go up or will it go down? Well, now it's 2.9 volts and 4.3 amps. So resistance is V over I. 2.9 divided by 4.3 gives us 0.67 ohms. So the resistance has gone up. If I get a much longer wire and put that in there, this time 3.1 volts is required to push a current of 2.1 amps around the circuit. So resistance is voltage divided by current. 3.1 divided by 2.1 gives us 1.48 ohms. And this is how a variable resistor works. A variable resistor has a very tightly coiled wire, and what happens is as you turn that dial, you're effectively lengthening the chain, you're lengthening the coil of wire, so you're pushing the electrons down along the wire, and that increases the resistance. So this experiment shows us that as the length goes up, the resistance goes up. Okay. So why is that? Well, it's harder to push electrons down a longer wire, and a longer journey is more difficult. So there's more resistance, there's more atoms or ions to bang into. So resistance is caused by those electrons banging into those delocalized, or those metal ions. Remember, metallic bonding is the electrostatic attraction between positive metal ions and delocalized electrons. So you've got these very closely packed ions together with electrons orbiting around them and being shared. So they're going to bash into fewer metal ions on a short journey than they are in a long journey. So increasing the length increases the resistance. Okay guys, that's all you need to know. Make sure you have a go at those questions for me, please. This is a required practical, so think about what will be the dependent, what will be the independent variable, what will be your control variables. So just going back to it for a second, what's the independent variable? The independent is the length of the wire. The dependent variable is the resistance. We have to take two measurements to do that. We have to measure voltage and current. So there are two dependent variables in this case. And the control measures, we need to use the same wire throughout. We need to use the same power source, so we need to use the same cell each time. We need to have the same bulb in there, and the same reading instruments. So hopefully you can see that as the length increases, resistance increases. Right, so make sure you can calculate resistance. V equals I times R, R is V over I. Make sure you can understand that Ohm's law is that voltage and current are directly proportional, so you get a lovely straight line going up, except you didn't when you did your work, because it was a bulb and that doesn't obey Ohm's law, and so a lot of things don't. And finally, to understand that increasing the length of a wire will affect the resistance. What other factors affect it? The temperature, the material the wire is made from, and the thickness of the wire. All of those are going to affect how many electrons can work their way down that wire at the same time. And that is resistance done, folks. Right, have a go at those questions. If you want to email me the answers, that's spot on. If you don't worry about it, and I will see you all soon.